Welcome to clickmyproject.com. Now we discuss about Fovea center detection based on the retina anatomy and mathematical neurobiology. In this process, we analyze the retina color image by using MATLAB image processing. It was used to find the eye diseases and also find fovea in eye retina area and then classify fovea in that area. We detect the Fovea center detection based on color eye font images. The retina anatomy constrained on the relative location of mathematical neurobiology and retina structure. The detection of anatomically feature is necessary because of computer-aided diagnosis and also several retinal diseases. Our proposed method is adaptive local illumination changes which are robust to the local distribution by using pathology in digital eye image. Using drive image, the result of detection of fovea center in 37 out of 37 images at 100%. Using DDP1 database, the result will be 82 out of 89. The result shows a better performance compared to the previous method. This is the flow diagram for our proposed system. In our proposed system, first we give the input image. The input image is like a retinal image, and then it's go to the green channel. In green channel is the pre-processed step. In the pre-processed step, we convert the eye fronts image into gray image. Analyze the image which have any noise. If we have the noise, then remove the noise by use Gaussian filter, because detection of fovea center is difficult to noisy image. Then generate the histogram equalization of pre-processed image. In this method, we convert the image into green channel image by applying the regional minima and geodesic morphological to reconstruct the image. It is useful to separate the optic disc and fovea easily. Then the green channel image is go to the optic identification process. In this process, identify the optic disc location using the superior and inferior nasal arcades that are located in the opposite side of the temporal arcades. Optic disc detection and neurobiological technique have two main stages. One is detection of the optic disc location and another is detection of the disc boundary. The optic disc location based on the vascular tree. After changing green channel, we found the optic region and boundary. The optic disc region is useful to detect the boundary. Also calculate the diameter of the optic disc. If we find the optic disc, then we go to the ROA image. In ROA image, inside the ROA, the fovea is located. The fovea by anatomical information. In this method, the ROA image have 160 into 160 pixel. ROA image is useful to detect the location of fovea. Then we finish the ROA process. Then we go to the smooth ROA. In this process, first we remove the bright spots and small bends in image by using fovea segment. Because we remove the bright spots because of the detect the fovea center clearly and accurately. Also remove the all Bayesian, which is useful to detect the accurate location. And then smoothing process, we select the fovea region. After remove the bright spots and small Bayesians, we identify the fovea region. The identification is useful to detect the particular fovea center. In this image, first we select the region of affecting area. Then we go to the fovea detector. The fovea detector is used to fuzzy C-mean clustering method. The algorithm is an iterative clustering method that produces an optimal C Bayesian phi, minimizing the weighted within group sum of square error objective function. Finally, the recommending images are classified to the fovea center. This classification is done in ANFIS algorithm. The adaptive neurophysics interpretation system or ANFIS is used to classify the images to get the final result. The result will be more accurate than the previous method. The acronym ANFIS derives its name for Adaptive Neurophysics Interpretation System. Using a given input and output dataset, the toolbox function ANFIS constructs a fuzzy interpretation system whose membership function parameters are trained using either a backpropagation algorithm alone or in combination with a least squares type of method. This adjustment allows your fuzzy system to learn from the data they are modeling. A network type structure similar to that of a neural network which maps input through input membership function and associated parameters and then through output membership function and associated parameter to output can be used to interpret the input or output map. The parameter associated with the membership functions changes through the learning process. The computation of these parameters is facilitated by the gradient vector. This gradient vector provides a measure of how well the fuzzy interpretation system is modeling the input or output data for a given set of parameters. When the gradient vector is obtained, any of several optimization routines can be applied in order to adjust the parameters to reduce some error measure. This error measure is usually defined by the sum of the square difference between actual and desired outputs. ANFIS uses either backpropagation or combination of least square estimation and backpropagation for membership function parameter estimation. In fuzzy system, it will classify the feature by using several rules. That rules will help to classify the data will be a normal or severe type or moderate type. Now I am going to demo our proposal system. First open the MATLAB and then right click the m1.m file and run that file, and then the process guide will be opened. First we load the input image from dataset. We load one image. It is the retinal based image. It is the histogram of the original image. It is the given input image. Then we go to the green channel process. It is the histogram equalization of pre-processed image. It is used to find the Fovea center and optic center, and it is the green channel of the original input image. And then we go to detect the optic disc edges, and it is the optic disc edges. It is used to find the Fovea on the retinal based image. Then we go to the ROI or region of interest of. We go to nearest to the Fovea, and then we detect the Fovea from the ROI image. It is the Fovea. Then analyze that Fovea for it is the affected the retinal by normal level or moderate level or severe level. Then we go to the analyze process. It takes few minutes for analyzing the image. The waiting bar will be open, and then the given image is the normal. Now we go to load the another image from dataset. Then the same process will be again, and find the green channel value, and then optic disc, and go to the region of interest and detect the Fovea and analyze the Fovea. And that Fovea is affected severe level in the retinal. And if we go to eject the window, then go to click the close button for close the guide, and the process will be finished. Thanks for watching video.